Hello my dear friend, welcome back once again to the second use of dimension equation, and that's to derive relationship between the physical quantities. As we had discussed in the almost 2 videos back, that we can easily derive the relationship between some physical quantities which are interrelated to each other, and how they are related, that also we can derive, whether they are proportionally related or inversely proportional, or by how much square or power, by how much exponent it is related. Those all things we can derive using the dimensional equations. All right, let me illustrate you. Let's say we are going to here derive relationship between a very famous example. It is always, I think, teachers gives the example of this, the time period of simple pendulum. All right, so simple pendulum is something like this. Let me give you a small figure. All right, this is the string, all right, the length of the wire, okay, and this is the bob, which is to move, here, and then it again swings up to there. All right, so let's say the time period is t is the time period of this simple pendulum, and this L is the length of this string. All right, L is length of a string, a kind of wire it is, very thin wire, and this let's say this bob has the mass of m. All right, it's not visible well. Okay, let's say this has mass, this has mass of m. All right, I'm writing these all because you don't know these things. You have not studied this time period of pendulum, so that's why. But in examination you don't have to do these all, making figures and all. You just start it. I will tell you how to do in examination later in later videos. First, let's understand the concepts. And definitely, the gravity is pulling it back, so it depends on g also. So acceleration due to gravity. And it may depends on the angular displacement, how much it is making. Like sometime it may be here, so that time, what is the angular displacement? What is the theta? So theta is angular displacement. So these are the 4 factors here in which the time period is related. Time period first itself, time period can be said to be related with the length of the string. It depends on the length of the string and how much heavier mass we have, and how much gravity is acting over there. Acceleration due to gravity is acting on that mass, and definitely how much angular displacement we had made. If you go here, then it will definitely try to get back here, because the gravity will pull it back like this, and one force is towards this. So one force is towards this, another force is vertically downward, so this will go this side. All right, well, we'll talk about later these things. So these are the main factors, and let's write the dimension of this. Okay, and my dear friend, angular displacement, angle do not have the dimension, so these are dimensionless quantity, keep in mind. Okay, time period's dimension is how much? Yes, that's t only, and length, that is L only. All right, you can write m0 L1 t0 like that also. Mass, simply m, all have the m L t, these all means like power is 1, and acceleration due to gravity, whatever type of acceleration it is acceleration, so it is L t minus 2. So we know the dimension of all, and now we are going to suppose few things. We're going to suppose that let's say our time period is proportional to length, and we don't know how it is, maybe inversely, maybe directly. So let's say time period is proportional to L with power a. So if this a is positive, it's directly proportional, and if it is negative, it means it's inversely proportional. Always keep in mind. All right, next one, let's say this time period is proportional to mass of the bob by the power of b. All right, and again this time period is proportional to, let's say, g with the power c. So again here in b and c also, if they are positive, it means they are directly proportional to that mass, and if it is negative, if c is negative, it means the g is inversely proportional. So you need to understand this. All right, and I'm going to suppose this equation 1, equation 2, equation 3. So combining all equation, I will get t is directly proportional to L to the power a, m to the power b, and g to the power c. And to remove the proportionality constant, as we usually we need to put a constant. So t equals to, let's say, a constant k times L to the power a times m to the power b times g to the power c. Always, the same process we're going to follow for every type of the relationship derivation. Whenever you're going to derive anything in future from your textbook or from the exercise given by your teacher, assignments, there you're going to follow the same process. So please see how I'm doing, and the next time you have to do yourself. Okay, so writing dimensionally now this equation, writing dimensionally, let's say this is equation 4. Okay, so I can say above equation 4. So the time has the dimension of t1, okay, and k is a constant, so constant do not possess any dimension. And this is length, so length is having dimension of a, all right. And this is mass is having dimension of b, and this is acceleration due to gravity, all right. This is acceleration, so it's lt minus 2 having the dimension of c. So let me write in the mlt format, so it's m0 l0 t1, and here l to the power a, and then here m to the power b, and here l to the power c t to the power minus 2c. Okay, now let's combine them in right hand side. So it's going to be m0 l0 t1 equals to l to the m to the power b l to the power a, you know, and then we have here c also, so a plus c, because whenever you get base same, power get added, you know. We have learned x to the power a times x to the power b equals to x to the power a plus b, you know. Base is same, then power get added, exponents get added, and then t is having minus 2c, all right. So in both hand side, you know, if you see, we have mlt, you know, both are same physical quantities, so we can equate the powers of, you know, the exponents of mlt. So equating the powers of ml and t, we'll get, you know, if you equate one by one, m to the power 0 and m to the power here b, so b equals to 0, I can say, and 0 equals to again a plus c, all right. So a plus c equals to 0, and 1 equals to minus 2c, so minus 2c equals to 1. So from here we can get that c equals to minus half, and using this relationship here, you know, this relationship here, what we can say that a plus c, that is a plus c is minus half equals to 0, so that's a equals to plus half, all right. And b we know already, that is 0, and c we recently get that as a minus half, all right. So abc we know now, and let's put the value of abc in equation 4. Our equation 4 is this one, all right. T equals to k times l to the power a, m to the power b, g to the power c. So let's put the value of them. Let me first write the equation 4. That's t equals to k l to the power a, m to the power b, and g to the power c. Therefore it's going to be t equals to k times l to the power a. A is here having power half, m is having power b, that is 0, and g is having power c, that's minus half, all right. So t equals to k times l to the power half, and now g to the power c, c is here minus half, so it's 1 by 2, and now t k m to the power 0 means that's 1, so we don't have to think about this now, and l is having power half, and g is having negative, so I'm just writing in denominator, and here from here our t is getting k and l over g root, all right, because x to the power 1 by 2 means inside the root x, all right. So our relationship is t equals to k times under root l by g, and now by the experiments, you know, yeah. And let me tell you one weakness of this dimension analysis, that we cannot find out the value of constant. I mentioned this in the previous video also. We don't know the value of constant. So what we can say that from the experiment and from various methods, we know the value of k as a 2 pi, all right. From various method, or you can say experimentally, we have find out we find k equals to 2 pi, all right. So our equation is going to be now t equals to 2 pi l over z, all right. So this is the time period of a simple pendulum, and this is how it is related with the physical quantities l and g, all right. And that was our main destination, to find out the relationship between the physical quantities, all right, deriving relation, all right. And that this is here. And you know, my dear friend, you may know this k, you may not know the value of k. There may be many type of the deriving relation you will get in the exercise in this chapter, but you won't know the value of k. So you can write this as it is now, and once you'll finish the whole section, you know, the whole session you'll finish after learning the basic physics, whatever you're learning this year, whatever the, you know, session, I mean after your semester or after the whole year of education of the physics, you'll you'll be watching a lot of physical relationship, lot of formula you'll see, and there automatically the value of k will come. All right, and then you'll learn, and when you'll give the exam at the end of semester or at the end of year, then that time you'll automatically know what is the value of k. This is the first almost initial stage of physics, so you may not know what is k, but later on you will definitely know what is this k. So don't worry about this k. Okay, whenever you get k, you can ask your teacher, or you can just leave it here in this time. So I'll see you guys in the next video with next use of dimensional equation, and that's gonna be to convert the values of one system of unit into another one. Till that time, please rate the video, subscribe the channel, and if you have any confusion, any doubt you need to ask, or any kind of feedback you need to give, any message you need to give me, then please feel free to comment below this video. I'll be really happy to reply in the comment section. Bye bye.